All right. Hi, guys. We are ready to move on to our next lesson. So far you've learned about ways to analyze data. You've learned about mean, which is the average, mode, which means the most occurring data point, median, which when ordered least to greatest is your middle. You've learned about the range, which is your highest data point minus your lowest data point, which shows how far your data is spread. You've learned about outliers, which we know can contribute to like the mean. If you have a really large number with a lot of small numbers, that's going to make your average different, or vice versa. If you have a lot of big numbers and then one small number, it's going to affect that average as well. You've learned about 5 number summaries, which take the lowest, highest, median, quartile 1 and quartile 3 of data. You learned that if you take your Q3 minus your Q1, that's called your IQR. That's the range of just your middle parts of your quartiles. Now today you're going to learn about a different way to describe data, and it's a more complex method, but it is called MAD, or mean absolute deviation. So this is going to be your last little bit of notes that go on this this set of notes. So I'm going to go ahead and just continue on. I'm going to put mean absolute deviation. Okay, mean absolute deviation. Let's kind of like try to unpack that ourselves. So we know that mean is the average. Absolute is positive. So like when we absolute value a number, it goes from negative to positive. And if it's positive, it stays positive. So it's the average. I'm just going to tell you positive distance. Okay, deviation. If you're a deviant, you're going against the grain. If you deviate from your plans, you are changing your plans. So I'm gonna tell you it's the average positive distance from the average. Okay, I'm just gonna help you out with that one. Okay, so if it is the average positive distance from the average, you are really finding out how far away each data point is from the average on average. So before we can do any of this, that's a lot of words. Before we can do any of this, we need to find the average or find the mean. If we're wanting to know how far each of our data points are away from the average, the first thing we need to find is the average. Well, let's use our movie theater data points. And luckily for us, we already calculated the mean. We have a mean from that last problem. Okay, we had a mean of 11. But it's really important I write down all these numbers again. So I'm going to go ahead, I'm going to rip this out so I can see it. Okay. So we're going to go ahead. Step 1, like I said, oops, I don't know why I put a line. It's not $sign. Step 1 is find mean, which we know is when you add them all together and divide by how many. Same fancy word for average. For our last problem, we know this was 11 because we took 9, 10, 10, 11, 12, 12, 13, added them all up together, got 77, divided by 7, we got 11. Okay, pretty simple. Step 2, we need to know how far each of our data points are from 11. Now, if this is simple subtraction like these numbers here, single and 2-digit, we know those. It just gets a little trickier when it's like decimals. But we know how far away 9 is from 11. That's 2 away. But I'm just going to model for you what you should do for this. So step 2 is subtract mean from each data point. Okay, so that would look like this. I'm going to take each data point, 9, 10, 11. Oops, I have another 10. 9, 10, 10, 11, 12, 12, 13. Those are all of my data points. And I'm going to subtract the mean from each of it, and our mean was 11. We are finding out how far away each of our data points are from the average. So 9 minus 11, negative 2. 10 minus 11, negative 1. 10 minus 11, negative 1. 11 minus 11, 0. 12 minus 11, 1. 12 minus 11, 1. 13 minus 11, 2. So again, so far, step 1 is add, divide. Step 2 is subtract. Okay, within your reason. So then step 3 is to absolute value all distances. Okay, if these are all the distances, the numbers are away from the average, okay, because 9 is -2 away, okay, from 11. It says absolute value, which I'm going to show you with my green, or I'll use a brighter color so you can really tell the difference. Absolute value is when you make it positive. So the absolute value of -2, 2. Absolute value of -1, 1. Absolute value of -1, 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 1 is 1. Absolute value of 2 is 2. Okay, so far, add, divide, subtract, make positive. You guys can do this. Step 4 is to find the mean of the answers from step 4. Find the mean of the answers from step 4. So now I take all these pink numbers and I average those. And we know to find the mean or average, you add together and divide by how many you have. 2 plus 1 plus 1 plus 0 plus 1 plus 1 plus 2, right? 2, 1, 1, 0, 1, 1, 2. 3, 4, 5, 6, 7, 8. Let me just try that again. 1, 2, 3, 4, 5, 6, 7, 8. And then you divide it by how many you have. 8 divided by 7 is going to get me 1.14, and then some dots because it's an irrational number. It goes on forever. So that is my math. That says that on average, each of my data points are 1 away from the average. Let me say that again. On average, each of my ages of kids who went to my movie are about 1 year apart from another person in the movie. That's all it does. It lets you know how close your numbers are. So if this was a big number, if let's say it was like 100, that would tell you that the ages of the people going are not very close because on average, they're very far away in age. The smaller the MAD you have, again, the closer your data is. This is just another way to tell you if your data is close or if it seems to be spread. Now, sometimes you can have data that's very close and have an outlier that's out there. And so it really affects your data. Okay, it's like out there, outlier. And so that can affect your data. So even though most of your data is together, that outlier that's really high or really low can change your average, right? So this is just a good way. If you have a smaller MAD, mean absolute deviation, that means your data is closer together because on average, the data points aren't far away from each other. This is now a time where you should write your summary. So your summary was how can analyzing data help us? So let me kind of help you through that. The mean helps you find the average. It helps you kind of know the middle, the average of the people are thinking. It accounts for all the highs and lows. The mode is the one that happens the most. My favorite example for mode that I like to use is if I'm asking my friends how many pizza slices they're going to eat, and most people say 2, then I'm going to make sure I order enough for most people to have 2. It's kind of when you want an informal quick number. The median, the middle, that's used a lot in data because it chops off the edges. When you use the mean takes in all the outliers. When you do the mode, you're only really knowing about one number. But when you do the middle, it's taking all the really big and really small numbers and chopping them off and kind of giving you a more concrete answer. Your range, again, tells you how far spread apart your numbers are. Okay. Your outliers kind of let you know if your data is close together or not, if you can identify your outliers. Your 5-number summary gives 5 different data points for your set instead of maybe just one, like the mean, median, or mode. And then your mean absolute deviation tells you how far apart each of your data points are from each other. Thank you for listening.